Here in the solitude of his study, Charles Darwin completed his landmark book on the origin of species. In it, Darwin attempted to explain how every organism that had ever lived evolved from a single common ancestor as a result of natural selection acting on random variations.
The idea of evolution itself, change over time, was not novel with Darwin. What Darwin did that was, I think, really revolutionary was to advance a hypothesis of common ancestry, that all living things were related.
He would have a branching tree pattern, and for a long time you would only have that one species, and then it would eventually branch into two species, and then more species, and different families and orders and classes. And in Darwin's thinking, given enough time, those differences accumulate, especially under natural selection, if the environment changes. Those differences accumulate to the point where 1,000 or 1,000,000 generations from now, your great-great-great-great-great-grandchildren will be a different species.
So it is both logically and almost aesthetically a unifying picture, a unifying image that pulls together the whole of life on Earth. And for many biologists, that kind of unification is very important.
Common descent and natural selection became the twin pillars of modern biology, and Darwin's branching tree of life its foremost icon. Yet despite the clarity and detail of his argument, Darwin acknowledged a problem that defied explanation: the Cambrian fossil record.
The distinctness of specific forms and their not being blended together by innumerable transitional links is a very obvious difficulty. I allude to the manner in which species belonging to several of the main divisions of the animal kingdom suddenly appear in the lowest known fossiliferous rocks.
When Darwin was writing The Origin of Species, it was well known at the time that the first fossils of animals appeared suddenly without precursors in the geological record. So there was a deep conflict between what his theory told him to expect to find, namely an abundance of transitional forms going back to that common ancestor for the animals, versus what was there in the fossil record.
Darwin knew that if his theory was true, the older rock strata directly beneath the Cambrian layer should reveal a progression of fossils connecting simple earlier forms to complex animals like trilobites through a trail of incremental steps and failed biological experiments. Such evidence would document the trial and error process of natural selection.
But Darwin says in The Origin, where are these transitional forms? They're not there in the fossil record. What we see instead are fully formed, discrete groups. Now that's a world-class puzzle for someone like Darwin.
And so it's very, very striking, and one can see why Charles Darwin was so puzzled by the Cambrian explosion, because he had enough knowledge even at that time to realize that deep in the Earth history, you just didn't find the animals.
If my theory be true, it is indisputable that before the lowest Cambrian stratum was deposited, long periods elapsed, and during these periods of time, the world swarmed with living creatures. To the question of why we do not find rich fossiliferous deposits belonging to these assumed earlier periods prior to the Cambrian, I can give no satisfactory answer.
Darwin was deeply troubled by the Cambrian explosion. He called it an inexplicable mystery. But he wasn't about to abandon his theory, and instead proposed that the animals just looked like they appeared suddenly because he thought that the fossil record was incomplete.
I look at the natural geological record as a history of the world imperfectly kept and written in a changing dialect. Of this history, we possess the last volume alone, relating only to 2 or 3 countries. Of this volume, only here and there a short chapter has been preserved, and of each page, only here and there a few lines.
So Darwin argued, well, perhaps paleontological discovery, digging through the rocks, needed more time, that the transitions were out there, that not enough collecting had occurred, not enough sampling, if you will, of the fossil record on Earth. And given time, those transitions would turn up.
3 decades after Darwin's death, Charles Walcott's historic work in the Canadian Rockies did nothing to fill the gaps in the tree of life or the fossil record. Walcott uncovered the remains of Cambrian animals unknown to Darwin, and each demanded its own unique progression of evolutionary ancestors, a trail of evidence that did not exist in the Burgess Shale.
Walcott realized that the Cambrian explosion of life was an even bigger problem than Darwin imagined. So, in an attempt to defend evolution, he reached back to Darwin's explanation of an incomplete fossil record.
Like Darwin, Walcott thought that the Cambrian explosion was an illusion. He was convinced that the fossils were there, they were just inaccessible to scientific discovery, and he expected that they would eventually be found someplace buried deep beneath the oceans.
For decades, Walcott's hypothesis was widely accepted, but untestable. However, later in the 20th century, new technologies led to empirical conclusions.
Once the oil companies started to drill offshore, they brought up what are called drill cores, and inside the core were hunks of sedimentary rock, and some of those rocks contained fossils, but none of them were made by animals that lived before the Cambrian explosion.
Since the 1960s, scientists have also used radioactive minerals and evidence of changes in the Earth's magnetic field to analyze and date undersea sediments. From extensive surveys, they have created this digital map that defines the age of the seafloor.
We now know that the oldest rocks on the bottom of the seafloor only date back to the Jurassic period, which means that on the standard geologic time scale, they're hundreds of millions of years younger than the rocks below the Cambrian strata.
If you are looking for the ancestors to the Cambrian groups, the last place you would expect to find them is out somewhere on the seafloor. Those rocks are much too young.
So how did the Cambrian animals emerge, and where are the signs of their evolutionary past? Darwin and Walcott both confronted and failed to solve this mystery. And today, the plot has thickened as science looks back to what the planet was like before trilobites and morellas first inhabited the ancient seas. According to standard estimates, almost 90% of the Earth's history took place during the Precambrian geological period. While our knowledge of the Precambrian is far from comprehensive, most textbook accounts include a similar chronology and chain of events. About 3.5 billion years ago, primitive life first appeared on Earth in the form of single-celled bacteria. Over time, these cells gathered into clusters to form blue-green algae that floated on the surface of the oceans. Life changed very little for more than 3 billion years. Then on the threshold of the Cambrian period, evidence of multicelled organisms first appears in the fossil record.
In the late Precambrian and at the Cambrian boundary, we're seeing the rise of larger organisms that had fluid skeletons and strong muscles, and they could burrow and they could crawl around. And as time goes by, we begin to see on the ancient seafloor sediments trails, little squiggles of where a small worm was crawling along. And they look like squiggles left by little tiny worms today. So from near 600 million years to 543 million years, more or less 50 or 60 million years, what we mostly see as far as living kinds of animals are these little squiggles.
There is also evidence that near the end of the Precambrian, the oceans were inhabited by jellyfish, sponges, and the mysterious Ediacaran fauna.
But if you go to immediately before the Cambrian, then actually you find something extremely puzzling, because you get large organisms, large fossils, and these are called the Ediacaran assemblages, and they have been one of the great headaches for paleobiology and also for evolutionary biology. Why? Well, because basically some look like animals, but other ones don't look like animals at all.
Some of them look like air mattresses, quilted air mattresses. Others look like a frond. They're not plants, but they kind of have that appearance.
So these ediacaran assemblages are bag-like, what we call sessile. Most of them didn't move, or if they did, they probably moved pretty slowly. It looks a rather sleepy, a rather dozy world.
Whether the ediacarans were actually animals or plants is still uncertain. But late in the Precambrian, they disappeared from the Earth. Then, long after their extinction, everything changed in a geological instant. In a spectacular burst of creativity, the basic blueprints for most of the animal kingdom exploded into being. And for the first time, biologically complex structures like compound eyes, spinal cords, articulated limbs, and skeletons appeared on Earth. To understand the speed of the Cambrian explosion, imagine the history of life compressed into a single day.
If we imagine the whole history of life on Earth taking place in one 24-hour period, the current standard estimates for the origin of life put it at about 3.8 billion years ago, let's say 4 billion. So if we start the clock then, our 24-hour clock, 6 hours, nothing but these simple single-celled organisms appear, the same sort that we saw in the beginning. 12 hours, same thing. 18 hours, same thing. 3/4 of the day has passed, and all we have are these simple single-celled organisms. Then at about the 21st hour, in the space of about 2 minutes, boom, most of the major animal forms appear in the form that they currently have in the present. And many of them persist to the present, and we have them with us today. Less than 2 minutes out of a 24-hour period. That's how sudden the Cambrian explosion was.
Since Darwin, excavations on every continent have revealed the magnitude of the explosion of life, an event that was clearly global in scope. Most recently, several discoveries in southern China have fascinated science and deepened the Cambrian mystery. An ancient mystery is etched upon these mountains. A story of primordial oceans and prehistoric life, of creatures stranger than fiction, and the controversy that has surrounded them for more than a century. Buried among these majestic peaks are glimpses of an event that transformed the planet in a moment of geological time. Compelling evidence, etched in stone, that challenges long-held assumptions about the origin of animal life on Earth. Simon Conway Morris has devoted his career to the study of evolution and the early history of life. Morris has staged expeditions on 4 continents and surveyed the intervals of geological time, while focusing his attention on the Cambrian period and evidence for the sudden emergence of animals in a veritable explosion of life.
Well, a Cambrian explosion is exactly what it says it is. It's an explosion. Now, not explosion in terms of pieces of animal flying all over the place. Actually, when biologists talk about an explosion, what they mean is effectively an enormous diversification, what we call a radiation. So we have, during the Cambrian, what appears to be the abrupt appearance of animals. We're filling the barrel with lots of different types of organisms, but we're also inventing nervous systems, we're inventing eyes, we're inventing how to move quickly. So the whole world is speeding up. It's an event where, in many respects, everything changes forever.
In 1886, the Canadian Pacific Railroad reached British Columbia and the Kicking Horse Valley. For the first time, eastern and western Canada were linked by a 2,500-mile steel artery that opened the Rocky Mountains to tourists, adventurers, and men of science. Among them was the geologist R.G. McConnell. Earlier in the year, McConnell had heard reports of a shale bed on the flank of Mount Stephen, just outside the town of Field. Railroad carpenters who had explored the area said it was filled with stone bugs. In September, McConnell climbed the mountain. To his amazement, he found unmistakable imprints of prehistoric life on most of the shales in the bed. McConnell was standing in an ocean of fossilized trilobites.
Trilobites are icons to the Cambrian, and there are billions of trilobites high up on the shoulder of Mount Stephen. And one reason for that is that as they grew, they periodically threw off their old skeleton and made a new skeleton. So basically they made many fossils through their individual lives.
McConnell collected hundreds of these fossils and sent many of them to other scientists for examination. News of his work soon reached the offices of the United States Geological Survey and Charles Doolittle Walcott, a leading expert on Cambrian paleontology. Walcott was fascinated by McConnell's reports, but had to wait almost 20 years for the opportunity to conduct his own research. Finally, in 1907, as the newly appointed secretary of the Smithsonian Institution, he boarded a train for Western Canada. Walcott spent 2 summers at Mount Stephen, collecting fossils and surveying the geology of the area. Yet despite his success here, he knew his exploration of these mountains was only beginning. Looking out across the Kicking Horse Valley to the Burgess Pass, Walcott set his sights on a corner of the Rockies untouched by the hammer and pick of any geologist. This is where he would move his expedition. On August 30th, 1909, Walcott led his team below this ridge, 15 miles north of Mount Stephen. There, legend holds, he stopped to examine a pile of shale that blocked the narrow horse trail. As he picked up a slab, the geologist noticed a faint but well-defined fossil he had never seen before, a delicate lace crab he later named Morella.
He knew plenty and plenty about the Cambrian. He was an expert on the Cambrian. He published many papers. And when you see this little Morella, it's only about 1 centimetre in length. You get out your hand lens, and you suddenly see that this is, shouldn't be there. This is soft-bodied, effectively. And I'm sure he realised in seconds what it meant. He must have.
In the summer of 1910, Walcott found a fossiliferous band in the ridge. After blasting a quarry, the geologist and his family unearthed thousands of exquisitely preserved specimens from soft-bodied animals previously unknown to science. He called the site the Burgess Shale.
There in Burgess Shale, especially the lower level which Walcott first exploited, the preservation is miraculous, it's astonishing. We find trilobites, of course, but we find many, many other sorts of arthropods, almost none of which are ever found in a typical Cambrian assemblage. So we can treat them effectively as being soft-bodied. They have almost no chance of being fossilized in normal circumstances.
Geologists believe that the animals of the Burgess Shale were buried quickly and alive by an avalanche of sediment that created an airtight tomb and prevented the decay of soft body parts like eyes, legs, and internal organs.
Now, in the animal Morella, very often there's a sort of what we call a dark stain. And I find this very intriguing because that dark stain evidently is the body contents are oozing out. So in other words, the animal is beginning to decay and then something stops it. On many of the arthropods, we have the most delicate branches, and you can see every single fine hair along them. Quite astonishing. Similarly, the antennae going out like that. In particular instances, we have some worms, so we see the outside of the body. We can see various things at the front which enable the worm to burrow through the sediment. But then you look at the animal itself and you can see this sinuous reflective line. And of course you say, oh, that's the gut. That's the alimentary canal. And then in certain cases, you actually look at one part of the alimentary canal and you can actually see food inside it. Shellfish, which is swallowed. It is a remarkable insight into a fossil you'd never expect to be fossilized.
The Burgess Shale was once part of a massive reef in the Pacific Ocean, a haven for a menagerie of life that thrived at the edge of what is now the North American continent. Throughout long periods of geologic upheaval, tectonic forces elevated these rocks and the fossils they bear more than 7,000 feet above sea level. Here, the basic body plans of major animal groups that still exist today, and many others now extinct, made their first appearance in the fossil record so suddenly that biologist Richard Dawkins noted, "It is as though they were just planted there, without any evolutionary history." These fossils gave science its first detailed look at the biology of the Cambrian seas. With computer animation, we can now bring that world to life. Like something out of science fiction, Opabenia was a creature so bizarre it still eludes classification. While its 5 eyes watched for predators, the animal captured its prey with a grasping claw. First described in 1899 from a fossil found on Mount Stephen, Guiwaxia has also puzzled scientists. This mysterious Cambrian animal is covered with overlapping scales and may have fed by scraping microscopic particles off the seafloor. The animal most frequently discovered at Walcott's quarry was Morella. More than 15,000 fossil specimens of this prehistoric crab have been excavated, most revealing multiple pairs of jointed legs and feather-like gill branches used for swimming. The anatomy of hallucigenia has baffled paleontologists since Walcott first discovered its fossilized remains. 2 rows of sharp spines on its back and more than a dozen needle-thin legs gave the animal the appearance of being upside down, even when it was right side up. At the top of the food chain was Anomalocaris, the undisputed terror of the Cambrian seas. Measuring up to 3 feet long, this super predator used barbed feeding arms to capture both hard and soft-bodied animals. It then devoured its prey with layers of razor-sharp teeth. Between 1910 and 1924, Charles Walcott collected more than 60,000 Cambrian fossils, many of which are still studied in museums and research centers around the world. But the treasures of the Burgess Shale represent more than a wealth of information about ancient life. They are also flashpoints in a controversy that began long before the great geologist ever set foot in the Canadian Rockies.